All right, 4.1, understanding polynomial expressions. So some of this will be a review from previous stuff you've done in Integrated 1 or in junior high, but there'll be some terms that'll be new as well, so we'll work through this. So initially, our essential question is, what are polynomial expressions? We're just going to kind of define what those are to start. And so we start with identifying monomials. So a monomial is an expression consisting of a number of variable or product of numbers and variables that have whole number exponents. Terms of an expression are parts of the expression separated by plus signs. Also remember that x minus y can be written as x plus a negative y, so that still fits with our plus sign, so subtraction still works. We don't have to rewrite it like that, but just remember that is the same idea. A monomial cannot have more than one term, and it cannot have a variable in its denominator. And then here's some examples. So as you see, single term, although there's three things there, it's still multiplied together, so it's counted as one term. Decimal, but that is our coefficient. We don't care what the coefficient is, we just care about the exponent, which is a whole number. Here we do have a fraction, but our variable is not in the denominator. Number is in the denominator, so we're good with that. Now over here, monomials. This one has two terms, this one has two terms because it's separated by a plus or minus sign. This one here has a whole number exponent, but it is negative, so we can't have a negative because really what that becomes is x over, or 0.7 over x squared. Same thing with this one, and then here we have a variable in the denominator. All right, so practice, what I want you to do is fill in this chart, and we'll discuss this in class, whether it's a monomial, and then a brief description of why. All right, so a little reflection. Explain why 16 to the 1/3 is a monomial, but x to the 1/3 is not a monomial. All right, so again, I have a written explanation. We'll discuss this when you come back into class. Same thing with number 3 there, is x to the 0 a monomial? So I have some brief answers jotted down there, and we'll discuss those in class. All right, so classifying polynomials. So a polynomial can be a monomial or sum of monomials. Polynomials are classified by the number of terms they contain. So a monomial has one term, a binomial has two terms, and a trinomial has three terms. So mon means one, bi, like bicycle, is two, tri, like tricycle, is three, poly means many. And so as we look an example here, we have 8xy squared minus 5x squared y cubed z. Now there's a lot going on there, but it is a binomial because there is two terms. They are separated by the plus or minus sign. Polynomials are also classified by their degree. The degree of a polynomial is the greatest value among the sums of the exponents on the variables in each term. So as we look at number 4 here, we want to classify each polynomial by its degree and the number of terms. So we'll start with number of terms. We have 1, 2. So this is a binomial. And our degree, we look for the most. So the first term has just an x squared, so that would be a 2. This one has a 3 and a 3, so that would be a 6th degree binomial. Now as we look at this one, we have 1, 2, 3 terms. So we have a trinomial. And then we look at the power. Now, this is just a number, so it's 9. So the power on that doesn't actually mean anything. We have a 3 here, and no power is written here, so that's a 1. So this is a third degree trinomial. All right, go ahead and come up with your answer for number 6 there. Is 5x to the 0, y to the 0.5 plus 5 a polynomial? And then explain why. Next concept is we want to be able to write polynomials in standard form. So the standard form of a polynomial containing only one variable is written with the terms in order of decreasing degree. The first term will have the greatest degree, the next term have the next greatest, and so on until the final term will have the lowest degree. Often not having an exponent at all, just being a coefficient. When written in this form, the coefficient of the first term is called the leading coefficient. In our example, 5x to the 4th plus 4x squared plus x minus 2 is written in standard form because you can see the exponents go from 4 to 2 to 1 to nothing. So that is a 4th degree polynomial because our highest exponent is 4. Written in standard form, it consists of one variable, and its first term is 5x to the 4th. That's our leading term, and the leading coefficient is 5 because it is in front of the highest degree term. So we want to write each polynomial in standard form, then give the leading coefficient. So I'll do number 7 here. So highest exponent is x to the 3rd. So we have 4x to the 3rd. And then we have an x squared. Then just an x. And then our coefficient. And then our leading coefficient, our LC, is 4. We would state that this is a third degree. And then fourth term, once we get past 3, we really just call everything the same. So it's a 4th degree polynomial. All right, so I want you to do the same thing with number 8 there. And last is being able to evaluate polynomials. So a skyrocket is launched from a 6-foot high platform with initial speed of 200 feet per second. The polynomial negative 16t squared plus 200t plus 6 gives the height in feet that the skyrocket will rise in t seconds. How high will the rocket rise if it has a 5-second fuse? So we want our height, and our height at any given moment is this equation here. And when we want to evaluate, all we're going to do is substitute in the value we want to evaluate for. In this case, we're looking for when it has a 5-second fuse. And so what I'm going to do is substitute 5 in for my t. And then work that out. Whether you do that in your head or do it with the calculator, you get h equals, going step by step here, we get negative 400 plus 1,000 plus 6. And then once we combine those, we get a height of 606, and we don't leave it like that. It's 606 what? Seconds, feet. So make sure we label correctly. So height of 606 feet. All right, so you have your quizzes to work on, and then answer that final question there, our essential question. Check in based on what we've learned in this. What are the polynomial expressions?